Okay, got another type 1 improper integral. What's a little bit unique about this improper integral is that I'm going to the left forever and to the right forever. So what I'm going to do is split this at a convenient location. And since let's see, 1 over 1 plus x squared um, looks like it has symmetry about x equals 0. I'm going to split it there. Um, no other reason. So let's do that. That means I'm going to go from, let's see, negative infinity to 0. And then I'm going to go from 0 to positive infinity. Okay, so basically I'm dealing with fairly much the same items, but I'm going to have a limit where t is going to approach negative infinity, and then I'm going to have where t approaches positive infinity. And let's begin that process. So I'm going to work this piece first, and I'm going to work it in green, and we'll bring that over here. So I've got negative, actually I'm going to redefine that as a limit. Come on, erase. Limit as t approaches negative infinity, and I'm going to go from t to 0 over 1 plus x squared dx. Okay, now you should hopefully recognize this. 1 over 1 plus x squared dx is antiderivative, is the arctangent. Actually, I'm just going to work down instead of over. So I'll put equals here. That's going to be the limit as t approaches negative infinity. Make my screen bigger. And of the arctangent of x from t to 0. I don't need that for a second. There we go. And so what we have is the limit as t goes to negative infinity of the arctangent of 0. Well, first of all, let's go to our arctangent graph. You have it as part of your review sheet that you're going to have for every test. So, but I'm just going to take a look at it here. I made a graph of it. And this is the arctangent. So, a few things you have, and again, you'll have this on your reference sheet. I know what the arctangent of 0 is. The arctangent of 0 is exactly 0. So, when I plug in 0 for arctangent, I'm going to get 0 minus the arctangent of t. Okay, so taking the limit of a constant is itself, so the limit of 0 is 0. So now what I want to do is take the limit as t goes to negative infinity of negative arctangent. Let's talk about this. Negative infinity means I'm going to the left. Let's go take a look at that graph. As we go to the left towards negative infinity, arctangent is getting closer and closer to negative pi over 2 because arctangent is only defined in between negative pi over 2 and positive pi over 2. So as we go to the left, you should know it's going to negative pi over 2. And again, you don't need a graphing calculator. That's on your reference sheet. So, and so the limit, and of course I have a negative, so I'm going to negative pi over 2, or I'm simply going to pi over 2. Let me zoom out of what I've been doing. I've just evaluated, and let me erase this because it's just kind of redundant, just the green part. And I figured out that is pi over 2. Now, I'm going to do the same exact logic on this side. Let me get a black pen. And so I'm going to find the limit as t goes to infinity of the integral from 0 to t of 1 over 1 plus x squared dx. Once again, the antiderivative of this is the arctangent. That's of x, sorry, getting ahead of myself. Arctangent of x from 0 to t. So I'm going to plug in t first and then 0. And the arctangent of 0, oops, other way, the arctangent of 0 is 0. We already know that. Now, all I need to do is take the limit of the arctangent as t goes to infinity, and again, let's bring that back up, going to positive infinity, which means I'm going in this direction to positive infinity. Arctangent is getting closer and closer to the boundary pi over 2. So this equals pi over 2. So let's go back up, and I just figured out this second part. So it is pi over 2 plus pi over 2. My final answer is pi. Hopefully that made sense to you. Let me zoom out so you can see everything. And that is all my work.